Chapter 7.5, we're looking at systems of inequalities. So here's some review on graphing some inequalities. So number one, when you have a solid line, when you have like a greater than or equal to or less than or equal to, meaning you can include that line, that would make the system true. And then if you have just a greater than or less than, then you would have the dashed lines. So what you can do here is, number one, you have to graph the equation, and then you test a point to see where you shade. So for example, for number one, I chose the interior here, 0, 0. 0, 0 is just a convenient number to choose. So I plug in x and y for 0, and I see, is 0 greater than or equal to -1? And that's true. If that is true, then every solution inside is true. I could choose any number in there, and that would make it true. And anything outside of it would make it untrue. So number two, again, I tested 0, 0, the point right in here, and that is true. 8 is less than 16. This is a circle with a radius of 4. And so that is that graph. Number three, x is a vertical line, and it's greater than -2. So therefore, I shaded to the right, and I tested 0, 0. And so that is true. Y is less than or equal to 3, so it's a solid line. And then less than or equal to 3, I plugged in 0, and 0 is less than 3, so that is true. Number 5 and 6, there are two ways to graph linear equations. So number one, you can think about it as finding the x and the y intercepts, and then after that, you do need to figure out what the slope is and which way it is shaded. So it is helpful to rewrite it in slope-intercept form. So notice right now is x minus y is less than 2. And so I guess if you think about it, if this is negative, then you're going to flip it and it's going to be greater than. But just solve for the slope-intercept form. So you get y is greater than x minus 2. So then I graph the line. Since it's greater than, it's dashed. And then greater than is above. I can check by plugging in 0, 0. And 0 is less than 2. I plugged it into the original. So whichever one you plug it into should make it true. For number 6, same thing. So you can find the x-intercepts. I found the x-intercepts when x is 0, y is -2. When y is 0, x is -2. And then I rewrote it in slope-intercept form. Y is greater than -x minus 2. And then I shaded. So just some general things about graphs of inequalities. It's the collection of all solutions of the inequality. To sketch it, you begin by sketching the graph of the corresponding equation, so whatever equation you're given. The graph of the equation will usually separate the plane into 2 or more regions. In each region, one of the following must be true. All points in the region are solutions of the inequality, or no point in the region is a solution of the inequality. So you can determine whether the points in an entire region satisfy the inequality by testing one point in the region. And so just some more pointers about sketching graphs of inequalities. If you need it, you can always refer to this as well. So here we're going to solve systems of inequalities and then use systems of inequalities in 2 variables to model and solve real-life problems.